Okay, Algebra 2, Unit 6, test review. We're going to go pretty fast through this. Number 1, growth, decay, or neither. So, you're looking for your B value. Actually, in all three of these, your A value is 1. So your B is whatever's being raised to the power of x, or some variation of x. Let's get focus here. There we go. So, in this case, B is 1/3. So that's less than, or that's between 0 and 1, so this is decay. 9/7, that's greater than 1. So your B value is 9/7, which is greater than 1, which is growth. And 0.89, that's between 0 and 1. So that's decay. Pretty easy on that one. Alright, you need to be able to rewrite into log form. So right now it's an exponential form, and the way I would do this is write the word log if you're going into log form. The base of your logarithm is just whatever's being raised to the power, in this case of x plus 1. Sorry, I don't know why it keeps doing this with the focusing. Let's focus here. There we go. So in this case 3 is the base of the log. And then the other side is the big number here. So you have the little 3, that's your base 3, and then you have 5. And then you set it equal to the exponent, which is x plus 1. Let's try it again. We're writing this into log form. Okay, this is going to be annoying. 1 second. Let's try that. There we go. So you're going into log form. Your base of the log is this x right here. The big number or letter that goes here is z, variable I should say. Then you set it equal to the exponent, which is y. Alright, so know how to do that. You should practice this. Rewrite into exponential form, so we're going the other way. You probably remember the trick I showed you is you take the base 6 and raise it to the power of the other side, so 6 to the power of 0 in this case. And then just set it equal to 1. You can write it this way or you can write it the other way, it doesn't matter. As long as you have 6 to the power of 0 equals 1. Here we have a natural logarithm, which means our base is e, and you might want to write an e in there. Okay. Because it's ln, you raise e to the 1, and even though we know that e to the 1 is just e, make sure to keep the 1 there because we're just rewriting, so you want to keep the e there. So we have e to the 1 equals that e. Alright. Number 4, we're going to calculate this without a calculator. Part A, you have log base 5 of 1. It doesn't matter what the base is. If you have a 1 here, it's automatically 0. That's something that's just a property you have to know. Part B, 625. It turns out that 625 is 5 to the power of 4. 5 times 5 times 5 times 5. Using that knowledge, we're going to take this logarithm. You don't change the base 5, but you replace 625 with 5 to the power of 4. And the trick is if these numbers match, this whole thing is equal to the exponent. In this case, 4. Okay, let's try this one out. Now, 1 over 10, that's the same thing as 10 to the negative 1. And that's nice because I don't have a base written here. Remember, if there's no base here, the base is assumed to be 10. If you need to write a 10 there, you can. So we have a base 10, we have a big 10. These match, so what this is equal to? Your exponent of negative 1. Remember, it's crucial. You got to make sure these match. If they don't match, you don't have an answer. This works with natural logarithms as well. You have ln of e squared. Or just remember that you have a little e here as well. And look, these match. This is equal to 2. Alright. These ones you do have to use a calculator. So honestly, it's just knowing how to use the buttons on the calculator. Log 64. There's a base 10 here. Your calculator is already in base 10, which is nice. So all you have to do for part A is type in log 64. And you get, we're around the 2 places. 1.81 would be that one. We have log base 2 of 98. The way you type that into your calculator is log 98, log 98 divided by log 2. Okay, so those are the buttons we're going to press for that one. So we have log 98, close the parentheses, and I noticed in class that some people were not closing them, and they're wondering why they're getting it wrong. So just a little helpful tip for you. Divided by log 2. So make sure to close parentheses, then hit the division sign, then type in log 2, and we get 6.61. And ln51, you have the ln button. It's directly below the log button. So you just hit ln, type in 51, and we have 3.93. Okay, not bad. Okay, we're going to expand these logarithms. Expanding means we're going to go from one logarithm to many. How many depends on the problem. So in part A, and this is one where I say look for division first, then multiplication, then exponents. So I don't see any division here. I do see multiplication. I see 100 times x to the 4th. So what does multiplication become? Oh, okay, division becomes subtraction, and multiplication becomes addition. So I'm going to rewrite this as log 100 plus log x to the 4. Okay? And then look for any exponents, and I do have an exponent 4, so this 4 is going to come to the front of the this log, not the front of the whole thing, by the way. And that's all that happened a few times in class, and again, that's okay, but just so you know, the 4 goes to the front of its own log, so I'm going to have plus 4 log x. Maybe you saw it already, but do you see that there's a base 10 here? And what's log 10 of 100? Well, 100 is 10 squared, so that means that this log becomes just the number 2. Again, here I'll show you on the side, and I'll show you in blue. So this is our answer, but in case you're wondering how I got 2 again, we had log 100, which is really log base 10 of 100, but 100 is just 10 squared. These match, and so that's why this is equal to 2 right here. Let's go ahead and do part B. Again, look for division first, then multiplication, then exponents. I do see division here. So we're going to separate this as log 4x squared. Notice I'm keeping the top of the fraction together so far. Minus log y to the 4. So now I have no more division. Now I go to multiplication. I do see 4 times x squared. I'm going to separate this. I'm going to separate this log into log 4 plus log x squared. Then I bring minus log y to the 4 down. So I'm not changing the second log. I'm just bringing it down. And then I look for any exponents. I don't see any here. Although, you know what 4 is? 4 is 2 squared, isn't it? So check this out, actually. I'm going to bring everything else down as it is. If 4 is 2 squared, that means that I can replace 4 with 2 squared. Then what can I do with all these exponents? These all have exponents. What do I do with them? I bring them to the front of their logarithm. So on this one I get 2 log 2, plus from this one I get 2 log x, minus 4 log y. By the way, this doesn't always happen. Like, let's say you had like log 5 here. You know, 4 could be rewritten as 2 squared, but 5 or other numbers like that cannot. So sometimes you just leave it as log 5. This one, however, we could have gone further, and so we did. All right, we're going to condense here. So we're just going the other way. Instead of going division, multiplication, exponent, we're going to do exponents, multiplication, then division. So in part A, I see the 5 can become the power of the x. I don't have a number here, so I don't need to move anything here. So my first step says log base 6 of x to the 5th plus log base 6 of 12. Now I have a plus sign between two logarithms. That means that I can combine these into one logarithm by multiplying these things. So I have log base 6, and then 12 times x to the fifth is just 12x to the fifth. And actually, I'm already down to a single log, so I can stop here. There you go. Alright, let's do the same thing in part B. M, N. These can become exponents. It's okay to have variable exponents. So I have log x to the m minus log y to the n. If I have subtraction between two logs, I get division. That doesn't mean log over log, though. It's still a single log, but what are you dividing? You're dividing this and this. So don't write log over log. That's a very common mistake. Just say one log, and also put parentheses and do x to the m. So that's the first thing we have over y to the n, and that's it. I'll do the rest of the problems in part 2.